The objective of this lesson is to find the perimeters and areas of similar polygons. You can use the ratios to compare the perimeters and areas of similar figures. If the scale factor of two figures is A over B, then the ratio of their perimeters is also going to be A over B, and the ratio of their areas is going to be A squared over B squared. So remember, a scale factor is just a ratio of two corresponding sides when we're looking at similar figures or polygons. So the A over the B represents the side lengths, the two corresponding side lengths of two similar figures. So the ratio of their perimeters is going to be the same as the scale factor, and the ratio of the areas is going to be the numerator squared and the denominator squared of that scale factor. So once again, just as a review of scale factors, how do you find a scale factor? You got to write the ratio of the lengths of two corresponding sides of the figures. And when you know the area of one of two similar polygons, you can use a proportion to find the area of the other polygon. And when you know the ratio of the areas of the two similar figures, you can work backwards to find the ratio of their perimeters. So let's look at some problems to see how we can use this. First problem, we're finding the ratio of similar figures. It indicates that the rectangles below are similar, and the ratio of the lengths of the corresponding sides is 6 over 8, or 3/4. So the first question asks, what is the ratio, smaller to larger, of the perimeters? Well, the ratio of the perimeters is going to be the same as the scale factor, A over B. So it's going to be 3/4. The ratio of their perimeters is going to be 3/4, just like the scale factor. And what's the ratio of the areas? For the areas, you take that scale factor, or the ratio of the perimeters, and you square the numerator and the denominator. So here, we're going to have 6 squared over 8 squared is 36 over 64, or reduce that down to 9/16 is going to be the ratio of the areas of these two figures. So let's look at problem 2. Problem 2, you're finding the area of similar figures. The area of the smaller regular hexagon is about 127.3 feet squared. So it's asking for the best approximation for the area of the larger regular hexagon. So let's compare the areas. We know that the ratio of the areas is A squared over B squared. And so A squared over B squared is going to be equal to, we're going to set up a proportion. The area of, we'll call this one area 1 on the smaller one, and area 2 on the bigger one. So area 1 over area 2. We'll set up a proportion. So the side of the smaller one is 7. 7 squared over 10 squared. It's the larger one. The area of the smaller one, it indicated, is 127.3. And we want to find the area of the larger one. So let's cross multiply these. 7 squared is 49. So we have 49 times the area of the second one if we cross multiply those. And then 10 squared is 100, and 127.3 times 100 is 12730. So now divide both sides by 49, and you're going to get approximately equal to 259.8. So the answer is C, 259.8 feet squared. So So now let's go to problem 3. In problem 3, we're going to apply area ratios. It indicates that it will cost Maria $150 to have carpet installed in a room that measures 12 feet by 10 feet. At this rate, how much would it cost her to have carpet installed in a similarly shaped family room with a larger dimension being 18 feet? So we have an 18 feet dimension instead of the 12 feet dimension as the first one. So cost of the carpet is a function of area, because carpet is usually priced per square feet. So we're going to look at the ratio that's formed by the areas of these two rooms. So I'm going to work this over to the left where there's more room. Let's look at the ratio of the dimensions first. Ratio of dimensions is going to be the larger of the two rooms where there's an 18-foot dimension. The smaller of the two rooms, it corresponded to the 12-foot dimension. So our scale factor, or the ratio of our dimensions, is going to be 18 over 12, or 3/2. So let's use that to find the ratio of the areas. The ratio of the areas is going to be 3 squared over 2 squared, which is 9 over 4, which is 2.25. It's our ratio of the two areas. So there's a couple of ways you can set this up. We can set it up as a proportion, which we would take the ratio of the areas, the 9 over the 4, equals the cost of the larger area is the one we need to know, over the cost of the smaller area they gave us to be 150. So since I put the larger number first, the 9 over the 4, on the ratio of the areas, then I'll put the cost of the larger one over the cost of the smaller one on the right. So cross multiply these, you're going to get 4x is equal to 1350. Divide both sides by 4, and x is going to be 337.5. So we're looking at cost. So that's $337.50. Or the other thing we could have done, since we had this rate for the ratio of the areas as well, we could have taken the 150, which was the cost of that smaller area, and multiplied it times that 2.25, and that would have also given you $337.50. So you can work that either way. You can either set it up as a proportion, or you can set it up and multiply it times that ratio of the areas as a decimal. In the last problem, you're finding perimeter ratios. It says the area of two similar figures are 32 meters squared and 50 meters squared. So it's asking what is the scale factor and what is the ratio of their perimeters. Now once we find the scale factor, the ratio of the perimeters is going to be the same, because the ratio of the perimeter, remember the scale factor was A over the B, and the ratio of the perimeters was also A over B. So once we find that, we'll have the answer to both these questions. So first they give us, though, the areas of two similar figures. So the areas, the ratio of the areas, A squared over B squared, is 32 over 50. Now if you take the square root of both sides, you will get the A over B is equal to square root of 32 over square root of 50. So if we simplify those two radicals, square root of 32, 32 is 16 times 2, and 50 is 25 times 2. So I can take the square root of the 16 out as a 4, leave the 2 under the radical. I can take the square root of the 25, which is 5, outside the radical, and leave the 2 under. So now if I simplify this by canceling out the square root of 2, then I'm going to get 4 over 5. So 4 over 5 is going to be the scale factor, and it's going to be the ratio of the perimeters as well.